Hi, I'm Jason, and my side project is to make robotic hardware cheap and open. Tonight's topic, roller bearings. Big ones are expensive. The large equipment industry solves this with a technology called wire race bearings. So let's take a page from them, and we'll see if we can't make 3D printed bearings take big loads. Our test bearings are all plastic, 3D printed races, and the rollers, they're cut from filament. This little tab closes up the fill port. Yeah, this isn't a calibrated mass, but given the load, I'm pleased. 2.85 millimeter PETG filament and a 3D printed cut jig are all we need. So sizing the through hole for a light interference fit means that as long as you don't have any burrs, the jig itself acts as a gauge. The difficulty with which you have to pull the filament through tells you something about whether it's consistent in diameter over the length. A quality electronics flush cutter is important here for the clean cut that we need. Let the jig align to both jaws of the flush cutter. We want a nice perpendicular roller. Somewhat surprisingly, I got repeatability smaller than 1/10 of a millimeter from part to part. Across the diameter, 2.80 millimeters, and the cylinder length that we're cutting, slightly undersized, at 2.72. So the rollers play nicely together, stagger stacked in the raceway. This part does dual duty. One, it holds the retention tab in for the loading port, and two, it gives my boot a little bit of a riser so my boots don't rub on the outer races. Inner raceway, outer raceway, you can see the loading port there. These are just 90-degree cuts because they're square cross-section cylindrical rollers. And then it's just load them all up, alternating, clocked at 0, clocked at 90, clocked at 0, clocked at 90, all the way around. And it's ready to go.